Okay, so for our first problem, this is our first situation. We have a steel column that has the following properties. The modulus of elasticity is 2000 GPa or 200,000 megapascals. The yield strength is 200 megapascal, or that is your Fy. This is your Fy. The length is 12 meters. The moment of inertia is this one. The area is 8,000 square millimeters. So we are asked to solve for your allowable stress. Walang sinabi sa equation natin kung ano yung gagamitin nating formula. Okay? So we can try to use the Euler backlink theory or the column theory. So, but here, I think the solution shown here is the column theory. But when we use the Euler backlink theory, you would arrive on, so you are asked for the allowable stress. If you are asked for the allowable stress, um, actually, it is not stated whether your column is a fixed or a hinge. So let's just say it is a hinge one, no? Okay, so your FA according to our formula, pag ito ay Euler ha, pero walang sinabi sa atin. Okay, let's just try lang to use para magamit natin yung formula ng Euler. That is pi squared E over L over R squared. So that is the formula. So if we have pi squared multiplied to the modulus of elasticity of 200 times 10 raised to 3 Newton per square millimeter, and your length in millimeter is 12,000 millimeter, and the radius of gyration, actually you can solve your radius of gyration by having your I over A. You have to solve for R, so that is square root. Okay, so we have your R could be the square root of 37.7 times 10 raised to 6 over your 8,000 square millimeter. So that is your radius of gyration. So as a result, your radius of gyration is equal to 68.648. This one. 68.648. So if we use that R here and take the square, so we have your stress, allowable stress using Euler method as your pi squared multiplied to your modulus of elasticity over your length and your radius of gyration. Okay, so it's too large, no? That is 11,292.143. So this only proves that the Euler formula is not applicable most of the time. So let's try using the column theory. Okay, for the column theory, we will check first whether the column is a long column or a short column. So solve for the slenderness ratio. And we also solve that. That is the square root of your moment of inertia divided by your area. And this is the value of your your radius of gyration. And since the type of support is not stated, we assume that it is hinged at both ends. So K is 1. And if we take your slenderness ratio or the effective slenderness ratio, we would have 174.806. Okay, So I do have some correction. I forgot to square the denominator here. Here, na may square to. So, supposedly, yung FA natin for the Euler method is 64.599 megapascals. So, I just remember it. Okay, so in this, let's go back here. So, your slenderness ratio is 174.806. Then, next thing for us to do is to solve for the compression index, and it is given by the formula square root of 2 times pi squared E over your Fy. Okay, so this would be the value. If it's correct, the value of your compression index is 140.496. And if we compare your slenderness ratio to your compression index, uh, your slenderness ratio is greater than your compression index. Therefore, our column is a long column. And so that we will use the formula for the actual stress of 12 multiplied to pi squared E over 23 slenderness ratio, squared of the slenderness ratio. And that would give us a 33.703 megapascal. So as you can see, if we compare sa Euler method, ang nakuha natin is almost twice, no? Twice ng consideration natin yung nakuha natin. So if that's so, if we consider this one, we consider that this is the capacity of our columns, maybe we would fail on the principles of the column theory. So it is much applicable for us to use the column theory. So again, refer to the next video for another sample problem.